some information that will surprise you. For the past 15 years, scientists have been using cutting-edge technology to investigate your family history. We've been delving into your distant past, and we've discovered something incredible. It's time we shared it with you.
A long time ago, your family were on the brink of dying out. Yet somehow, against impossible odds, they managed not only to survive, but to become the most successful people on the planet. Come with me, and I'll tell you something that'll change your view of the world. It's the story of your family and how they conquered the Earth.
What if I told you that scientists have discovered a time machine, a portal that has allowed us to see back into ancient history? And what if I told you that for the past 10 years, I've been using this time machine to gather information that has been rewriting history, your history? And where does this information come from?
Blood. It's one of the world's most evocative substances. To many people, it represents the essence of life, a religious sacrament, a gift from the gods. But to me, it embodies the past. Because inside this tiny crimson drop is the greatest history book ever written. It's the story of a journey, the journey of our species, and each of us is carrying a unique chapter.
But it's only in the last decade that we've discovered how to read these stories. A window on the past that archaeologists could only dream of. A time machine hidden in our genes. My name's Spencer Wells, and I'm a geneticist. The adventure began for me as a young researcher when I was lucky enough to work with a special man. I've tracked him down here in Venice. His name is Luca Cavalli-Sforza. Luca was the first man to realize that blood could be the time machine to reunite us with our ancestors.
Evolution is history. Biological evolution is a genetic phenomenon. So unless we look at the genetics, we don't understand our history, we don't understand why we are made the way we are made.
This is how it started. In science, every now and then a big new idea comes along. It happened back in the 50s. What if we could use blood to learn about our most distant ancestors? The question became an obsession for Luca. He gathered up blood samples from populations around the planet. Why? To build a family tree for the whole world.
We saw that we could reconstruct a tree for these populations. We didn't know what it was supposed to be, but it made some kind of sense.
Luca had made the first steps toward a monumental truth that everyone alive today might be related, but his results were still hazy. It's the 1970s, and Luca's out in Central Africa sampling the blood of the Biaka and Mbuti people. He had a hunch that isolated tribes could give him a clearer picture of our distant past. He was right. They could. It really was possible to work out distant family lines from blood type, and the key lay in the blood of isolated populations. Flash forward to the early 90s. I was lucky enough to be one of a chosen few working with Luca at Stanford University in California. There was a scientific revolution in full swing, and the buzzword was genetics. While everyone else was talking about the future, we were looking backwards into the past. Blood was the time machine, and we were time travelers. Soon, we were taking Luca's work onto a new level. 10 years on, and we're ready to rewrite history. There are now some 6 billion people spread across our planet. Not so long ago, our species numbered little more than 10,000, and their world was a single continent, Africa. Then, something happened. A small band left their African homeland on a journey into an unknown, hostile world. You are one of their children. Who were these people? How did their children come to populate the entire Earth? I'll explain more about how we know this a little later. We are desperately close to the answers. We're on the verge of understanding the greatest journey in the history of our species. And yet...
Listen, I'll be honest with you. I've got a problem. I've spent nearly 10 years checking and double-checking the details of this journey until I have complete and total faith in our results. And the upshot? A story that's, well, frankly, it's impossible.
If our ancestors made the journey I believe they did, they would have had to be superhumans. The speed, strength, and resilience required to conquer the world defies belief. And yet, there it is, written in our blood.
What do you do when 10 years worth of work leaves you with more questions than answers? I'll tell you what I'm going to do. I've made a decision. I'm closing the door in the lab, hanging up my white coat, and heading out into the real world. I'm going to retrace their journey for myself.
But my task is daunting.
I know the genetic results, they're supported by clear data, and yet I still find it amazing that only 50,000 years ago, the ancestors of all of us were still living in Africa. It seems like such a short period of time on an evolutionary timescale. Look at it this way. Humans evolved from apes, and apes first appear in the fossil record about 23 million years ago, a huge expanse of time. So compress it down to a year. In that case, apes appear on the 1st of January. Toward the end of October, the first ape men arrive, the first ancestors to walk upright. Amazingly, it's not until the 28th of December, nearly the end of the year, that the first fully modern humans arrive on the scene. And even more incredibly, it's not until the 31st of December, New Year's Eve, that they leave Africa to populate the rest of the world.
And by New Year's Day, our ancestors had made it to the furthest corners of the globe. But how could they have made such a journey so suddenly, so swiftly, and so successfully? That's what I'm off to find out. It hasn't been an easy decision. I'm not just leaving my cozy lab, I'll be leaving behind my young family too. But this is a big story, and I want to be able to tell it with absolute confidence. To do that, I've got to walk in the footsteps of our ancestors, to face hardships, to feel the elements that so nearly wiped them from the face of the earth. It's a journey that both terrifies and exhilarates me. First stop, the place where it all began, the birthplace of every human being alive, Africa. Our genetic time machine has revealed a small surviving tribe, the direct descendants of our earliest ancestors. Unlike the rest of us, they stayed on here, and I'm hoping I can learn from them why some of their family left to start the greatest journey in history. Come on, let's meet the family. Kalahari Desert, Namibia. I'm here to find an extraordinary ancient tribe of people, the San Bushmen. Our research shows that their distant relatives left Africa and set in motion the family tree of mankind. From them stemmed every color, creed, and nationality alive today. We know the fathers of mankind started their journey from here, but why did they leave? I'm hoping the few survivors they left behind, the San Bushmen, will help me solve this fundamental question. 50,000 years on, I hear their numbers are dwindling fast. Soon they could be gone entirely. I'm arriving not a moment too soon.
Hello? How are you? I'm Spencer.
And my 2 children, they are boys. This is my wife.
Amazing. Do you want to see a picture of my daughter? This is her in her school uniform. What's her name? Margot.
I have to explain to them why I'm here. But how do I begin? For a start, what's Bushman for geneticist anyway? I sense this is really going to be tough for a lab rat like me.
I just want to tell you a little bit about why I've come here. It's mostly to find out about your way of life. I'm really excited to be here. You know, it's such a dream for me to get to meet the San people, the Bushmen. In a way, you carry a secret in your blood, and you can think about it like a family tree.
I explained the tree was just like the family that we all belong to. My family line is one of the small fractured branches at the very top, while theirs is the oldest on Earth, the biggest branch at the base of the trunk. I get the feeling I'm not explaining this at all well, but they're way too polite to say so. This is really quite embarrassing.
So it's a great privilege for me to come and meet my distant relatives and the people who give us a glimpse of all of our ancestors. So in one sense, we're all Khoisan. We're all San people. It's just that my skin is slightly redder.
We would like to thank you for the information that you brought for us.
This is like a dream for me. Everything predicted in their blood seems to be written in their faces. It's like looking at a composite model of every face from around the world. The eye shape of East Asians, the high cheekbones of Mongolians, the mid-brown skin that could turn darker or lighter. So how do I know that of all the people on Earth, the San are direct descendants of our oldest ancestors? I'll try to explain a little better this time. I work with DNA, our very own manual of life. It's in our blood, in every cell of our body, orchestrating our life processes. DNA is a ladder of just 4 linked molecules, A, C, G, and T, strung together in pairs in an incredibly long and complex sequence. If laid out, the DNA from one person would stretch to the moon and back 3,000 times. In our cells, this chain is broken into 46 bundles called chromosomes. Because of its sheer length, DNA is prone to develop small glitches in its sequence. They're called mutations. Everybody has them. When they occur, we pass them on to our children. We call these inherited mutations markers. As our chromosomes pass down through the generations, they carry these markers with them. They write our history. They are the source of our time machine, the way we can see back to our earliest ancestors. The markers I follow are found only in men, on their Y chromosome, the chromosome that makes men men. But of course, men don't travel alone, and the journey of man is the journey of everyone.
I was walking through the village and I saw that they had massive piles of these sitting around everywhere. We call them monkey oranges. And they taste pretty good. They're a little bit like papayas. But I thought it would be a good idea to use them to explain exactly what we mean when we say we're following genetic markers. This is a man at some point in the past. The thing that makes him a man is his Y chromosome, a piece of DNA that's unique to men. When men have sons, they pass on their Y chromosome to those sons. Again, it's what makes them sons. So if we imagine that this man had 2 sons, they would have essentially identical DNA on the Y chromosome to their father. So they would get his Y chromosome in effect. And if we imagine that they also have sons, those sons, the grandsons of this very first man, would also have essentially the same DNA. But occasionally, when we pass on these pieces of DNA, we get a change in a single letter in the sequence. We can call those mutations or markers, and that's what allows geneticists to trace descent. Now, I've represented this marker with a little strip of tape, a little black bar. And just like before, all of the sons of this particular man will have essentially the same Y chromosome, so they will inherit this marker. And in that way, the marker acts effectively as a badge of descent, a marker of descent from this particular man, and that's what we follow. Now, as we move further down the tree, most of the sons will inherit just that single bar, but occasionally, as we saw before, we will get a second change in the Y chromosome. A second marker appears, showing descent from a particular man, in this case, this person, who has first that marker, which came from that person back there, but an additional unique change on his Y chromosome, which he then passes on to all of his descendants. So in the people that we're talking about living in the present day, in this part of the tree, they've got two markers. They clearly trace their descent from this man, but the first marker, remember, arose all the way back there, all those generations ago.
The San Bushman markers are quite unlike any others found outside of Africa. In the world's family tree, their branch is the first to split from the rest. That's how I know they must be the oldest tribe on Earth. And now I'm here with them, looking for clues to find out why their ancient brothers and sisters left this place. The first thing I noticed was their incredible language. They speak with clicks and other sounds totally alien to me.
And the word for zero? Kora.
They try to teach it to me.
And for two? Ta. And three? Nani. And four? Go. I can't get that for you.
Is this strange language a window on the past? Did our ancestors speak like them? Merritt Rulin, a linguist from my old university, Stanford.
Bushman is the only family which has clicks. Those kinds of sounds. None of the other world's language families have these sounds. So this is really what makes Bushman languages different from all of the other world's languages. There's a reasonable hypothesis that these clicks are in fact ancestral sounds which have been lost in all of the other world's languages, probably lost just once in Africa. And then the group which lost these clicks left Africa and spread throughout the entire world.
When I ask another colleague, paleoanthropologist Richard Klein, also from Stanford, he goes even further.
Speech is more than just communication. It's also the way you model your world. You can ask what-if questions. What if I mounted this piece of stone on the end of this shaft in this way, and I put a string across this boat thing, and I tried to shoot the shaft with this boat thing? What if? You know, that kind of question is something that probably requires language to be answered effectively, even if it's just one person talking to themselves in their mind's eye.
50,000 years ago, Click was a new and complex language. There'd been nothing like it before. But there were other innovations too. They showed me this. It's a spear tip finely crafted from bone. It might not seem like much today, but when our ancestors started using it, it was the last word in technology. The smart missile of its day.
In every detectable archaeological respect, meaning the manufacture of art, the widespread use of materials like bone and ivory and shell, the burial of the dead with ceremony or with ritual. In every detectable archaeological respect, after 50,000 years ago, you see this burst of creativity. There's a big difference in behavior. The form is fixed and culture takes off.
Interesting. So they didn't use stone.
No, they didn't use stone. They used the bone.
The bone.
Yeah.
Because it's more efficient.
Yeah.
The arrows were finer. And
Yeah.
toward me. Yeah, you have more control. Great. So you just want to make it very round and very smooth.
Now we're getting somewhere. When they left Africa 50,000 years ago, the ancestors of these New Age people had state-of-the-art hunting technology and a brand new language to communicate ideas.
Now, how far back can I pull it?
You must be careful, otherwise
Further?
it breaks. Can't hold. Have to cook it right.
Ah, one more. Going to the right.
But they weren't philosophers, they were hunters. Next, the Bushman showed me how these new skills were used. Like forensic detectives at the scene of a crime, the San Bushmen read clues left in the ground and get inside the mind of their prey. 50,000 years ago, this kind of thinking would have given them an immense advantage over their competitors, anyone who couldn't think like this. Piers Latranche has worked with the Bushmen for years. He's seen firsthand the best trackers in the world.
No, it's no.
If you look on the edge of the track over here, it's still got, it's got a very, very sharp edge.
Yeah.
And that's basically their main thing working, saying, okay, the age of the track. And then they'll take another
And how
sign.
precise can they be? I mean, to within hours?
Yeah.
Wow.
Yeah.
These are the prints of a wildebeest. Now we're on its trail. A lion will wander across hoof prints without a second thought. If it can't see the animal, hear it, or smell it, it simply doesn't exist. It would have been the same for our distant ancestors. But 50,000 years ago, these trackers learnt to see into the past and into the future. The hoof print told them that an animal had walked this way in the past, and if they followed its tracks, in the future they'd fill their bellies. According to Merritt Rulin, hunting was only the beginning of the advances made possible by language.
Language is basically responsible for all human behavior, whatever it is, and these new hunting methods and the exquisite hunting methods that these people have clearly reflects advanced language. The advanced language is what allows people to do all of this extraordinarily complicated and complex kinds of activities. Its language lets us do an enormous number of different things, and hunting is just one of them.
Back on the trail, the tracks lead us to the prey.
If you look over there, he's lying under the tree there.
Okay, yeah.
You just see his tail swishing. So what he's doing, he's checking to see where the wind is blowing. The wind is all right. Okay.
Okay, so what are they doing now?
So this is what would be their typical stalking pose, actually, sort of slight dropping down. Try and lower their profile on the ground.
The Bushmen are keeping a low profile, but unfortunately they never stood a chance. The two great white hangers-on yakking behind them blew it.
So they figure that it's not even worth trying.
No, once you've been busted, you've been busted.
Yeah.
It's not going to be worth it. The element of surprise is gone.
Yeah.
Is there a parallel between what I'm watching and the skills our ancestors developed 50,000 years ago? I asked Piers.
Oh, absolutely. If you take it just on a basis of natural selection in its purest form, you look at every animal around, it's going to be the survival of the fittest. And to me, you can use the same analogy for mankind. If you didn't have the brains, sorry, you were left behind.
50,000 years ago, our ancestors experienced a quantum leap in thinking. But this doesn't tell me why they left. Were they driven out? Did they develop a newfound curiosity? I'm told the answer may lie 800 miles south of here, on the South African coast. Now this is a cave with a mysterious past. Long before the quantum leap, This natural shelter was a home for humans. Then they suddenly vanished. Why? De Kelder's cave contains human bones dating back 80,000 years. What were these early occupants like? I asked Royden Yates, an archaeologist from the University of Cape Town, to describe them to me.
That's the lower jaw. What's important is the presence of a chin. So this is somebody who would not be very different in appearance to any human being living today.
Dress them in a suit, stick them in an office, couldn't tell the difference.
Absolutely, nobody would give them a second glance.
They may have looked like us, but the people who lived here weren't as smart. These people lived here before the quantum leap in thinking. Royden showed me their tools.
You find blade-like pieces.
And these would have been chipped off a core.
That's
a
right.
central piece of stone.
That's right.
Chop up a bit on the edge.
And then you find over here other pieces which have a natural point. Now, better developed examples such as this could be used as a tip to a spear.
And these would be hafted onto some sort of stick.
Yeah.
Yeah. They are very crude.
If I gave you a block of quartz and a hammerstone, I'd challenge you to produce a flake formed like that.
He's right. I can't make a stone tool, but I'll live with it. The point is that the people who lived here hadn't thought of using materials like bone. These are the kinds of simple stone tools that humans had been making for hundreds of thousands of years. But when did they disappear?
The dating that we have shows that Middle Stone Age people were not in this shelter after 50,000 years ago.
Something clearly happened there then.
Something clearly happened there.
Mm-hmm.
50,000 years ago. Sounds familiar, doesn't it? What was it that caused these people to suddenly vanish? Richard Klein thinks it's a miracle mankind survived at all.
It's extremely difficult to find archaeological sites that date between 60 and 30,000 years ago. Animal and plant populations crashed and human populations would follow. So it's not that there weren't people there, say in southern Africa between 60 and 30,000 years ago, but there were so few of them that they have virtually no archaeological visibility.
Julia Lee Thorpe, a paleoclimatologist from the University of Cape Town, explained how the drought would have caused a dramatic drop in sea levels, leaving this cave high and dry.
There was a very sharp drop in temperature around 72,000 years ago. And at that point, the sea would have receded quite rapidly from the site. So the site would have changed to a different kind of place.
What would these changes have been?
Well, the sea was retreating and eventually retreated to about 40 kilometers away. So this place would have become an inland site. And the set of opportunities that you see around you today, with an enormous amount of seafood, which was obviously eaten, would not have been available. It's not possible to carry seafood 40 kilometers.
What sort of evidence do we have for these climatic changes?
Well, we don't really have evidence for sites underwater, or at least not direct ones. But what we do have is a great deal of evidence for global climate changes over the long term. And we usually extract those from very long ice cores in, for instance, Antarctica, and also marine cores off the coast of southern Africa and all around the world. We can extract little creatures. These are called forams, which are really very tiny. They look like little grains of sand. But there's a great deal of information that's locked up in these little creatures. They're made out of calcium carbonate, and we can measure the oxygen and the carbon isotopes. And from that has been extracted a sea level curve for the last couple of 100,000 years. And that tells us a lot about what sea levels were doing and what the ice caps at the North Pole and the South Pole were doing.
Between 70 and 50,000 years ago, those ice caps were expanding. We're talking about a worldwide catastrophe brought about by monumental changes in climate. The world was in the grip of an ice age. The polar ice sheets had expanded southwards, locking up much of the world's moisture as ice. Deserts in Africa grew, and sea levels everywhere dropped, leaving caves on the South African coast high and dry. Inland, lush pastureland turned to desert, and prey became extremely scarce. Hunters who once had easy pickings now found themselves desperately searching for food. Humanity was on the verge of extinction. Miraculously, some were thrown a lifeline, that quantum leap in thinking, which meant a small band could now think the unthinkable and leave Africa forever. Where did the next human remains outside of Africa turn up? The Middle East? Europe? India? No. Australia. You think that's impossible? I thought so too, but guess what? That's where our ancestors turn up next, and no one knows how. There's no evidence of a journey by foot, and 6,000 miles of open ocean tell me that sailing was out of the question. So how did the descendants of the Bushmen get to Australia without leaving a trace? Maybe the answer's there. Let's go find out. Australia, the most remote continent on Earth. Yet after our ancestors left their home, this is the very next place where we find their bones. How did they get here, and why is there no evidence of their journey?
This is an absolutely extraordinary place. I've studied biology for nearly 20 years, and yet when I come here, I have to throw most of what I know into the bin. The animals and plants you find here are unlike those anywhere else in the world. That's because the last time Australia was connected to the other continents in the main line of mammalian evolution was over 100 million years ago. What this means for our story is that when we get to Australia, we find that humans are the only primate species living here. That means they must have come here from somewhere else.
Mankind had to be an African import. The most obvious route would have been along the coastline of southern Asia, but so far there isn't one scrap of archaeological evidence that they came this way. Neither has a trace of their presence been found in the genes of those living along the route. Something doesn't add up. So I'm off to Lake Mungo in western New South Wales. I've come here to try and find out if the first Australians really show up as early as people suggest. Apparently, many years ago, I would have been walking on the shores of a lake. This was home to an ancient people, the very first settlers in Australia. I'm looking for their remains, but if these rocks hold any secrets, they're not telling me. It's not till I meet up with archaeologist Doug Williams that this place makes any sense. Through his eyes, a barren wasteland comes to life. If you know where to look, the blowing sands of Mungo can reveal precious archaeological treasures, long buried and last seen by an ancient people.
Is that another lift?
Yep, that's an artifact. That's a flake. Yep. Sometimes you can get stone tools that have been used for scraping wood or something a bit harder. Tiny flakes will come off the sharp edge.
Mm-hmm. So what would it have been like living here for the people who made this thing?
Oh, I think it would have been really quite a rich place to live. I mean, you look out across the lake, it would have been a fairly wide expanse of water. It would have been quite a rich environment.
Ah, looks like a bit of charcoal or something.
This is the remains of a small fireplace. You can see staining of charcoal in these darker patches and more generally through here. Interestingly, it has these small bones, and it's actually a fish bone. Mungo is like this. A lot of the evidence we find is, you know, we're quite personal and poignant, you know. Someone's a night in someone's life 40,000 years ago. It's, pretty special.
We were stepping back in time. A community numbering as many as 200 lived here, eking out a living in this beautiful place. Suddenly, my lab seems half a world and tens of thousands of years away. But for Roy Kennedy, a descendant of these ancient Mungo people, this site feels like home.
When I visit this area and these burial sites around here, it's just like walking out to an ordinary cemetery and watering a grave. To me, it's very special.
But how long ago did the Mungo people live here? The distinctive colored bands in the sand are the key to dating any find. The red layers date back over 100,000 years, way before any sign of human habitation.
If you had to guess, knowing what you know about the site, what would you say?
I'd suggest in the range of 30 to 40,000 years.
It's incredible. I mean, it looks like it was done last week.
Yeah, well, certainly the bones are in good nick, aren't they? Yes, yeah.
Yeah.
They're incredibly ancient. The very oldest remains are dated to 40, maybe 45,000 years ago.
Having been here to Lake Mungo, I am convinced by the dates. Humans clearly were living in Australia very soon after they left Africa. And yet, this only serves to highlight the problem. How did they get here so quickly?
There's no evidence for a land journey, and a journey by sea? I just don't buy it. 6,000 miles of ocean is surely impossible. It's a long shot, but just maybe the descendants of those earliest settlers might hold a clue. The Aborigines are famous for their tradition of oral history. They call them songlines, and they tell the story of their beginnings passed down by word of mouth through the generations. Perhaps there's something in their songlines that hints at a journey. Roy from Mungo.
I don't know. That's a curly question, that one. I don't know. See, I believe that we come from here, and I think I will always believe that.
I've hit a dead end, but I've got the bit between my teeth and I'm heading north to Laura in Queensland. Do the rock paintings there hold clues to a possible migration?
Windmill. There's a big hill no doubt. That's why we got water out.
But hard as I look, I can't see any evidence of a journey.
From here, right.
And when I ask Greg Inabla Goodbye Singh, an Aboriginal artist from Queensland, he really lets me have it.
You mentioned with DNA testing that you've got now will trace us back to Africa. I don't believe that.
Why not?
Because if our stories aren't correct, you know, if they are a myth, the way that you guys might believe they are, and we know they're not, why isn't it possible that the Africans actually come from us? You know, we branched out from here.
Yeah. It's complicated to explain. In a way, what I'd like you to think about the DNA stories we're telling is that they are DNA stories. That's our version as Europeans of how the world was populated and where we all trace back to. That's our songline.
Yeah.
We use science to tell us about that because we don't have this sense of direct continuity. Our ancestors didn't pass down the stories. We've lost them, and we have to go out and find them. And we use science, which is a European way of looking at the world, to do that. You guys don't need that. You've got your own stories.
We know where we come from. We know about creation. We know we come from here. We didn't come from nowhere else.
This really isn't going very well. Tradition rarely sits well with cutting-edge science. The Aborigine songlines say that mankind originated here in Australia, no stories about journeys. But the blood of Aborigines tells me that they've inherited a very ancient marker from Africa. It's around 50,000 years old, while Africans have no trace of Aboriginal markers in their blood. The human traffic was strictly one way, from Africa to Australia. The big question is, what route did they take? 50,000 years ago, the Ice Age had locked up the world's water. Sea levels were lower, making Indonesia one landmass. Australia was joined to New Guinea. Since then, rising sea levels have covered up any trace of their presence along this route. If these first African migrants traveled this road, then their genes and the elusive Australian marker might survive somewhere. I'm going to India to see if I can find any genetic trace of the Africans en route to Australia. If I can, it'll be the first direct evidence that native Australians came this way. Let's go see if we can make history. Madurai in southern India. My mission? To try and find the missing link. I'm looking for the genetic marker found today in Australian Aborigines that shows their ancestors traveled through India on their journey to their new home.
It's incredible to be here, and it really is like diving into a sea of humanity. There's so many faces.
It's a long shot, but someone out there may be carrying the genetic link I'm looking for. To help me track down the marker, I've enlisted the help of an old friend, Professor Pitchapan. We'll use his lab and its equipment for as long as it takes.
Hi, good to see you again. Oh, good. How was everything? It's been quite a while.
He took me off to a quiet cafe so we could talk. Quiet by Madurai standards, that is.
We've been following this coastal migration to Australia. So this is the reason we think that the Australians were able to get from Africa to Australia so quickly.
Yes.
Is that they followed a coastal route.
There is absolutely no archaeological evidence for the existence of ancient man in the South India.
Right. Let's get to the map.
Yeah.
Given what you know about the people living in southern India, which population should we sample?
Yes, there are many.
As we worked out which villages to test, the full reality of our experiment hit me. We were looking for a needle in a haystack the size of India, but Professor Pitchapan was upbeat.
Maybe after your study, it may prove that the genetic evidence is better than archaeological evidence alone, probably, right?
Well, with any luck.
Yes.
The following day, I set out to sample an isolated village west of Madurai. This is exactly the sort of thing Luca started doing all those years ago. These villagers are a prime sampling group. They've lived in this region for generations with few outsiders marrying in. The more indigenous and isolated these people are, the easier it should be to find the ancient marker. If it's here.
Name?
Rajendra. Rajendra.
And address?
Genes are passed down through generations, so first off I take a detailed family history.
Okay, age?
55.
And intercaste marriage?
Okay.
Okay. Mother tongue?
Mother tongue Tamil.
Okay. Religion?
Hindu.
Hindu.
Remember I only sample men? The thing is, without the male Y chromosome, my hunt for markers would be virtually impossible. Let me explain why. Chromosomes come in pairs. We inherit one from each of our parents. With each new generation, the two chromosomes get chopped up and reordered, making each baby a unique combination of their parents. When that happens, it's bad news for me because I lose my marker trail. It's chopped to pieces by this genetic shuffling. But the Y chromosome is different. It doesn't get reordered every generation. Instead, it passes unchanged from father to son. and so do its markers, creating a perfect genetic trail for me to follow. But of course, men don't travel alone, and the journey of man is the journey of everyone. Somewhere here, 50,000 years after his journey, I hope to find the marker of the ancestral grandfather of the Aborigines. It feels good to be out in the field. Every sample you take, you can't help but wonder whether this guy will be the one. But the next stop is the lab. There, it's death or glory. You thought I'd hung up my lab coat? Well, so did I.
We've managed to collect several hundred blood samples from around the Madurai region. It's taken us days and days and days of work. And now we've got them in the laboratory, we've got a huge amount of work still to do. It's not just about collecting the sample, because we have to go through a purification procedure before we can get to the DNA and find this marker we're looking for. The first step involves getting rid of the red blood cells, the things that you might think of when you imagine blood, the stuff that carries the oxygen around your body. Then we get rid of the rest of the proteins, and we get down to a solution which is quite pure. We're ready for the last step, getting the DNA out of that. We want to add something to dehydrate the DNA molecules. So we add isopropyl alcohol. With any luck, we will see the DNA come out of solution. Looks a little bit like cotton at this stage. And there it is. I love this stage. I've done it thousands of times, and yet it still amazes me every time it happens. And it really is the essence of what we're looking at. This molecule is a historical document. Now, the final stage, down inside the solution, and snag the DNA, and lift it out. Voila, pure DNA. And there we go, and ready to move on to the next step.
We store the DNA samples in a refrigerator to preserve them. So far, so good. Now we have to analyze this stuff. It's a 2-hour process. Then we've got another 300 samples to go.
We are going upstairs to the sequencing machine to load the samples on. And the idea behind this machine is that it's a bit like a sieve, a molecular sieve. And it's going to separate the sequencing reaction products on the basis of their size, their length. And by reading up a ladder of these, we can actually tell what the DNA sequence is, the sequence of letters in the code, A, C, G, G, T, and so on. Quite a high-tech machine, pretty exciting piece of kit. And it's right down here in this room. Power back up, because if the sequencer stops in the middle of a run, you're going to lose all your data. So you have to make sure you have power the whole time. And it's in here, in this room, protected from the environment. And here we are, the sequencing machine, that molecular sieve. Now the sieve bit is actually a chemical matrix that's inside of this tiny little tube, less than 1 millimeter in diameter inside. This is what the DNA is going to be forced into via an electrical charge from one end of the sieve to the other. We've got the data from hundreds of samples on the computer here, and now my job for the rest of the day and maybe into tomorrow is to go through each one of these sequences looking for the tiny difference that distinguishes the coastal marker, the thing that leads us to Australia. So it's going to take quite a while, a bit tedious. Sometimes I wish I'd done something other than science.
If the marker's here, it'll give itself away as a tiny spelling mistake, in just one of the 4 letters that spell out the story of our past, ACGT. I'm searching for just one accidental change in a sequence that's 6 billion long, from C to T. Is that it? Yes, a misprint of just one letter, but just enough, hopefully, to change history.
I've got some really exciting news.
Oh, good.
Let's
Okay.
take a look at it. I'll show
Yeah.
you. If you look at this particular position, see that change
Yes.
from C to T?
T, yes.
That's the marker.
We've done it. This tiny spelling mistake occurred around 2,000 generations ago. It proves that our African ancestors did pass through here on their way to Australia. In the end, one man from a small village west of Madurai had the answer. It had been passed down to him from the very first humans to set foot in India. And here he is. One microscopic change rewrites the history of an entire continent. And that feels pretty awesome.
Fantastic. We should really celebrate.
In this case, the genetics is really leading the way because there is no archaeological evidence for a human presence in India until 30 or 35,000 years ago. It's amazing for me to think that as I look out on the subcontinent of India, that people are carrying this signpost in their DNA.
From Africa to Australia, and now, for the first time, the missing link we found in India. The genetic evidence of modern man's first coastal migration to Australia. Most of the route would have been pretty easy, requiring the same beachcombing survival skills learned in Africa. But there was one final obstacle. Even at the height of the Ice Age, the coastline didn't quite reach to Australia. There were still 150 miles of open ocean. A pivotal moment in our history. The quantum leap in our thinking strikes again. Modern man's ability to imagine a world beyond his horizons had taken him to the other side of the world.
Although we have no direct evidence for the methods used by these coastal migrants to reach Australia, reach it they did by around 50,000 years ago. And we have a clear genetic trail leading out of Africa along the entire route. But that only accounts for around 10% of the world's population. The other 90% took a different route, and that's where we're headed next.
The descendants of this second wave of explorers would become Europeans, Asians, and Native Americans. The odds of survival were close to zero. How did they make it? How will I ever make it? So far, we've revealed how the very first people to leave Africa had made it to Australia by 50,000 years ago. But what about the rest of the world? What was their journey? This fridge contains blood samples from populations scattered across the globe. Chinese, Russian, Native American, European, Indian, they're all represented here, and they share one thing in common. It's a marker, inherited from a single man. We've discovered that this group was the second to strike out from Africa, and they took a different route, to the Middle East. The Middle East, around 45,000 years ago, the bridge between Africa and the rest of the world. Makes sense. It's an obvious land route out of Africa. But why take it?
The time when our ancestors left Africa was the middle of an ice age. Now, This doesn't mean there was a lot of ice in Africa. In fact, it was just a few degrees cooler in the tropics, and it was probably much more comfortable. It's not as if they're suffering from cold. What they're suffering from is drought. What this does is to push all the animals and their predators in the Sahara out into North Africa, out into the Middle East.
And from here, they were poised to launch themselves on the rest of the world. So where next? The genetic markers show that one branch from the Middle East made its way swiftly into India. This small group, traveling down into India from the north, was so successful that their numbers quickly multiplied. They soon swamped nearly all traces of the previous coastal migration. A second wave headed for China. Here, bounded by sea and mountains, they remained in isolation, developing a distinctive appearance. They were also to become the largest nation on Earth. But the genetics reveal more.
It appears that East Asia was settled by two waves of migration, one going to the north and one going to the south of these mountain ranges, a bit like an ancient genetic pincher movement, still visible in the blood of the people living there today.
These were massive undertakings. In the virtual blink of an eye, mankind had reached as far afield as India and China. In comparison, it's only a short hop into Europe. You'd expect humans to have settled in there, too. But they hadn't. While humans were peopling Asia, in Europe, they were nowhere to be seen.
I've always had a particular interest in this part of the world. The story gets a little more personal here, because although I'm American, my ancestors originally came from Northern Europe. But how far back can we trace that ancestry? And in particular, who were the first Europeans? The archaeology tells us that it took them nearly 10,000 years to get here from the Middle East. I've always wondered why.
It turns out the answer lies underground. This is Pech Merle, an enormous system of subterranean caves and tunnels in southern France, and home to a breathtaking array of priceless artwork. The artists were my own ancient ancestors, the first Europeans, also known as the Cro-Magnon people. Could these paintings be clues to their journey here? If anyone can help me work this out, it's archaeologist Michel Lorblanchet. He's made a lifelong study of these prehistoric painters. He explained that these ancient Europeans were the first cavemen with an artistic side.
This is the first time that man draw in caves with beautiful animal drawings. This is the first time.
Why do you think it begins at that time?
Why? Big question. I believe that at this time, Cro-Magnon was arriving. He was a newcomer arriving in this area, and he discovered the cave first. And the cave became sort of sanctuary.
But if Europeans were newcomers, where had they come from? The paintings were like postcards from an ancient world, of a journey. Michel explained that these picture postcards described a journey all right, a journey through the Ice Age. Mammoths, bison, wild horses, ibex, all roamed the frozen earth. But the Middle East wasn't frozen. Where had they been? Wherever they'd come from, they'd toughened up along the way. But I really couldn't believe what he showed me next.
What's that? Bear scratches. No, the bear were spending the winter in the cave, hibernating. You see, they had big clothes.
Bears lived in here. These people must have been fearless.
It was dangerous, yes, to visit the cave from time to time.
I think these people were just so incredibly inventive in the same way that we are today, that they could they could manufacture what it took, make up houses, clothing, and things of this sort very quickly. Very quickly, it means in a geologic eye blink.
Just as well, life must have been pretty brutal.
I've seen the drawing on the ceiling.
The man who traced those figures, what would his life have been like?
He was a hunter. He was a
Actually, the term premeditated killer comes to mind. This guy had the strength, speed, and wit to hunt the giant mammoths in his paintings. Michel shows me how huge this guy would have to be to reach the ceiling.
You see the back of the mammoth here, the head, the trunk, the front leg here, the belly, but the hind quarter are missing because they are too far from the rock.
So he was perched on that rock and stretching.
Yes.
It's quite a distance.
That's true. In fact, this man was a very tall man. He was more than 6 feet high, 6 feet tall.
That's taller than the average French man today. Why? Richard Klein.
Cro-Magnons arrived there with African body proportions, really adapted to much warmer conditions. When they arrived in Europe, it's interesting that their physical proportions are more sort of tropical African. They're long and kind of skinny. And that tells me that they had the cultural buffer, the clothing and the housing, that were the main thing that allowed them to adapt to very cold climates.
But clothing and housing aside, anthropologist Nina Jablonski believes that Cro-Magnon had adapted in physical ways that suggested a colder, darker life.
One of the greatest challenges in reconstructing the ancestry of humans is actually to put ourselves back in the time before humans started migrating all over the world. Because people living in equatorial Africa are living in a hot environment, the skin must have been able to sweat very efficiently so that people could keep cool. And also because that skin was naked and therefore was prone to damage from ultraviolet radiation. And so the skin of our ancestors was dark, full of the natural sunscreen, melanin.
Sunlight produces vitamin D, vital for healthy bones. At the time my ancestors first ventured into Europe around 35,000 years ago, their skin was already getting paler in order to absorb more light.
Almost certainly the first people to go into Europe were quite lightly pigmented. This is because Europe, with latitudes in the 40s to low 50s, is, well, a region of fairly low ultraviolet radiation throughout the year. Populations living in Europe who were not coastal populations had to have fairly depigmented skin in order to allow enough ultraviolet B rays into their skin to synthesize the necessary amount of vitamin D that they needed. Coastal populations were very interesting because if they had access to fish, a very vitamin D-rich food source, then they could, in a sense, afford to be a bit darker than their hinterland brethren. But one of the things that we have to think about when we talk about the populating of Europe is that the people who went into, especially some of the northern areas, had certainly, well, they were wearing clothes. They weren't naked. They were covered with furs or some kind of simply sewn clothes. And so they had less of their skin actually exposed to the sun. So that's something we have to take into account too. When you wear clothes, you have less skin exposed, and the skin that is exposed has to do more work in synthesizing vitamin D.
The Ice Age was to cut these first Europeans off, eliminating any contact with the rest of the world. In isolation, they developed distinctive traits. Their hair color changed, the shape of their noses changed, even their height. Today, people with European ancestors, like me and these French boule players, look pretty different from our distant relatives. But why had it taken our ancestors so long to arrive here? Whatever kind of journey they made, it's clear that they developed a whole new range of life skills along the way. So why did it take my ancestors 10,000 years to get to Europe from the Middle East? And why had they changed so much? The accepted theory was that they made their way around the Mediterranean and up through Turkey. Then, our research threw a wrench in the works.
Until relatively recently, we had no reason to doubt that the first Europeans had followed a direct route out of the Middle East. And then, quite by chance, we uncovered evidence that they'd come from somewhere else entirely.
Turns out, when they left the Middle East, my European ancestors went on a tough and grueling detour. I'm going to pick up their genetic trail in a faraway land that begins long after these rail tracks have run out. As the sampling of the world's populations mounted, I tackled one of the greatest genetic blind spots of the world. Since childhood, I've been fascinated by characters from along the Silk Road. Traders and travelers like Marco Polo, and conquerors like Genghis Khan. I traveled to the ex-Soviet republics of Central Asia, little-known parts of the world, to sample the blood of their descendants.
We're in Bishkek, the capital of the former Soviet Republic of Kyrgyzstan. I first came here in 1996, and you really had the feel that you were coming to a very remote place. You know, some of the villages that we visited in Kyrgyzstan, we were the first foreigners that they'd seen since, 200, 300 years ago, perhaps.
When I first came here, this was new ground, untrammeled by any other Western scientist before me. For nearly a century, it was closed off behind the Iron Curtain. Even today, it's one of the most remote parts of the world. In this isolated land, I collected the blood of over 2,000 people. That was when we discovered that their blood held a remarkable secret, an ancient marker. I recognized it immediately. Nearly every man in Western Europe was carrying it, from Norway to Spain, Ireland to Austria. So my European ancestors hadn't taken the obvious route from Africa via the Middle East. Instead, they had passed through Central Asia 40,000 years ago. That was why they had taken so long to reach my homeland. But why would they do that? How did my ancient family from the Middle East wind up here, in this wilderness? William Calvin thinks that yet again the weather played a critical role.
Worldwide, you're getting droughts, you're getting forest fires, but the next year you're getting a lot of grass and a lot of grazing animals. And that's opportunity for the humans that survive the crash.
And for opportunity, read food. Honing their hunting skills and adapting to the colder temperatures, these African hunters followed the grasslands into modern-day Kazakhstan. The discovery of the Central Asian marker had changed our understanding of the journey made by the first Europeans. But was Europe the only destination for these formidable Central Asian hunters? Did their journey take them anywhere else? We widened our search and were in for an even bigger surprise. The markers seemed to be everywhere we looked. From Europe, through Asia, Russia, North and South America, the list seemed to be endless. We'd uncovered an astounding secret. If Africa was the cradle of mankind, then Central Asia was its nursery.
Bizarre. Sea of faces. And you can tell so much from a face. Or can you? Where are we now? We could be anywhere across the continent of Eurasia, but in fact, we're right at the very heart of it, in Central Asia. China is a few miles in that direction, Afghanistan a few hundred miles to the south. This is really the crossing point, the central part of the continent of Eurasia.
And I've come back for a very special reason. Hidden in the samples of those 2,000 Central Asians was one extraordinary individual. His name is Niazov, and he's directly descended from the man whose DNA, 40,000 years ago, had a tiny spelling mistake, the Central Asian marker. This genetic marker has spread throughout the Northern Hemisphere and been inherited by over 1 billion people. Branches of Niazov's ancestors went on to people Europe, parts of India, Russia, and America, but Niazov's family has always stayed here. Analyzing his DNA for the first time was an extraordinary moment. In an instant, I knew we'd discovered something very important. Now we're going to meet him. After nearly 2,000 generations, Niazov still lives in Central Asia. I'm excited about meeting him again, now that I fully understand the history he holds in his blood. But with a war raging less than 200 miles away in Afghanistan, making it across the border could be a little dicey. About half a mile from the border post now.
Hoping that we'll be able to get through all right. It's a bit touch and go. We've heard that Kazakhstan has locked down its borders because of the situation in Afghanistan. Possible refugees, possible Islamic militants. Everything's a bit touchy right now. About 500 meters from the post now. We also know that you're not supposed to film or take pictures at these border posts, so hopefully they won't notice us doing that. Logging down all the passport numbers. It's very interested in mine.
They might not even let me through, and I may not get to see the man whose blood has unlocked the secrets of the greatest journey ever.
Yeah, he eyeballed me.
How am I going to get out of this one? I'm on the track of one man whose blood tells the story of the most extraordinary journey in history. The children of this man's great ancestor became Native Americans, Europeans, Asians, and Russians. Some even made it down into India. But I'm being held at a border near a war zone. After 4 hours of bargaining, we were allowed into Kazakhstan. We're on our way.
We left eastern Kyrgyzstan at about 9 o'clock this morning, and it's 9 o'clock at night now. But very, very excited. We're about to go in and meet somebody who plays a critical role in our understanding of the genetic history of Eurasia. He gives us a direct line back to the ancestors of most Europeans, Native Americans, and a lot of Indians. So let's go see him.
Здравствуйте. Очень приятно. С вами тоже очень приятно.
Should take the shoes off.
Пожалуйста, Паша, давай так. Проходи ты.
This is an extraordinary moment. You can make discoveries in a lab, but to put a face to a genetic marker as ancient as this, well, for me, it's truly amazing. He may be shorter than I am, but he's a genetic giant in our history. I'm gonna have to give him my blood speech, though. Hope it doesn't put him off.
What if I told you that your blood takes us back in history 40,000 years? Your lineage takes us back to the very first Central Asians, before Uyghurs, before Pamiris, before Tajiks, the very first people who lived here. Do you know what DNA is?
Вы знаете ДНК? He have heard.
So it's the blueprint. That it's your instruction book. It's how to make
То есть это
another version
ДНК
of you.
дает вашу детям.
Now, the thing that we've been studying is known as the Y chromosome. And this is a small piece of DNA that doesn't really do very much except to make you male. So your Y chromosome you got from your father.
Чтоб чистый.
То есть вы
Чистый.
Вот мой отец.
Pure.
This is a picture of his father.
Вот отец.
Вот который в центре, да?
А это дедушка.
And a grandfather.
Дедушка.
That's great.
Father and grandfather.
That's fantastic. So that is a lineage, okay? Your Y chromosome came from him to him to you. Now, if we trace back even further, so we go from you to your father, to your grandfather, to his father, and so on and so on and so on, back through nearly 2,000 generations. If we do that, we reach a single man, one man.
То есть, когда мы это делаем, то есть вы, допустим, один человек, берем как человек,
Who was living in southern Central Asia.
Который живет в центре Средней Азии, то есть Евразии, в центре континента. Мы живем, да?
Да, Средняя Азия.
Сердце.
Around 40,000 years ago. Now, this was a very important man because he is the ancestor of Europeans, Native Americans, and many, many Indians. So I can tell you with absolute certainty
Я могу вам точно сказать, с полной уверенностью.
Your Y chromosome and his Y chromosome and his Y chromosome, they've been here for 40,000 years.
Спасибо.
Thank you.
Мой кровь из нас чистый.
That means my blood is pure.
So congratulations.
Поздравляю.
Very interesting blood. It's absolutely fantastic to be able to do the work I do. I'm very lucky.
Я очень счастлив. Это просто фантастически то, что я делаю и что я нашел.
Every day is like solving a puzzle. I go into the laboratory and I get a result and it solves a mystery about
То
history.
есть каждый день у меня как бы решаю какие-то загадки. Я прихожу в лабораторию, начинаю что-то делать и получаю абсолютно уникальные результаты. То есть каждый день как бы загадки, каждый день.
Спасибо.
But the most amazing part is to be able to come back here and tell you the results that I found from your blood.
Я счастлив то, что я после того, как получив результаты, я смог приехать опять сюда и сказать вам об этом.
Спасибо.
So I'd like to thank you for giving me both intellectual pleasure and real friendship and enjoyment.
Я хотела бы сказать вам спасибо за то, что вы мне дали просто интеллектуальное удовольствие, то, что я ученый, получил такой результат, я очень рад. И пожелать вам здоровья и счастья.
Спасибо.
So to your very important blood, which has brought us together.
Что мы стали друзьями, и что у вас очень важная кровь.
Чтобы приехали чаще. Снимали штуку. Я вам благодарен, что вы издалека пришли.
I'm very thankful that you came from the far.
Большое спасибо.
Thank you very much.
Well, thank you for meeting with
Я
us.
так боялся, что они меня делают.
Turned out the poor guy thought a doctor was coming to tell him he had cancer. No wonder he looks relieved. Genetically, we're so close. Yet from here in Central Asia, the descendants of Niazov's ancestral grandfather ventured out to give us an incredible diversity of looks. One group traveled west along the plains of Asia to become the first Europeans. But one branch of Niazov's family reached the Americas. Their children are the Native Americans, from the Inuit to the Incas. To get there, they had to embark on a journey into climatic extremes beyond anything endured before. Remember the Ice Age? Well, 20,000 years ago, it was at its most extreme. And yet, our research shows that that's when they headed straight into its bitter heart. Some of them are still there. Niazov's ancient marker shows up in a nomadic tribe deep in the Russian Arctic. They're called the Chukchi, and they're survivors from the Great Migration to the Americas 15,000 years ago. The Chukchi aren't exactly easy to find. They live on the northeastern end of Russia. In order to get there, I've had to come to Moscow. It's the middle of winter, and this is the only place to get a flight that goes anywhere close. Finding this tribe isn't going to be easy, because they're nomads. I'm hoping the Chukchi can show me how those Central Asian hunters could survive a journey through the heart of an ice age. But this flight is only the start of my journey.
We've flown east from Moscow about 5,000 miles, and this is it, the end of the line. A place called Anadyr, an old Russian settlement. We're headed inland to see the Chukchi people. Don't know how we're going to get there, though. Could get quite interesting.
The Chukchi live a further 400 miles north, inside the Arctic Circle, where temperatures can drop to nearly 100 below. For me, the only way to get any nearer is by chopper, but I'm told the weather up there has turned to storm force, and all the aircraft are grounded. It's a wonder people can live here today. It's so cold they've got to build everything on stilts, protecting buildings from the permafrost. I'm put up in a bare 5th-floor apartment in town. How long I'll be here is anyone's guess. The Chukchi are as close as I can get to the first Arctic travelers. I'm desperate to see how they live here. They don't even have heating or electricity. But if the weather doesn't improve, I may never find out. I've been here 5 days now. I really couldn't have come at a worse time of year. I've been given all this Arctic clothing so I won't freeze. The coldest I've ever been is the freezer back in the lab, a balmy 20 below. Eventually, I get the call I've been waiting for. There's a gap in the weather, and we're going for it. This may not be mission impossible, but it sure feels like it. I don't really know the risks involved in the next leg of the journey. Somehow I suspect I don't want to. How can anyone live down there? It's strange, but being truly alone is exhilarating.
Absolutely unbelievable. Just incredible. It is amazing here. It's like being on the moon. Incredible flight. One of the most beautiful things I've ever seen. Gorgeous. Really gorgeous.
The next leg is a bus ride to a town called Amguema, 120 miles inside the Arctic Circle. The air is even colder, but at least they have houses.
It's about 5 o'clock in the morning. Temperature is minus 25 degrees. We spent the night here in Amguema village. Now we're headed up to the tundra. It's about a 6-hour trip in one of these, an ex-Soviet tank. Gotta find out which one I'm going in first, though. Back here, the gear. We'll need that.
My guide hasn't arrived yet, so we're heading off without him. I've been told he'll meet us later, nearer the Chukchi camp.
Here we go. The bus uptown. See you in the tundra. We're heading up into the tundra to meet the people who are the direct descendants of the people who populated the Americas 15,000 years ago, at the height of an ice age. And the fact that I get to tell this incredible story and actually go on the journey that the genes have shown us, it's just amazing. This place is absolutely beautiful, and it's like being on another planet.
I know we can get to their general area on our own, but the Chukchi are nomads and will never find their exact location without our guide. I really hope he shows. At last he appears, and I'm about to get another lesson in human endurance. It turns out he's been walking for the last 6 days and nights to meet me.
Vladilin, you're from this village, Donkarem.
Да, я с побережья, коренной.
Yes, I am from coastal Chukotka.
And you walked.
Yeah.
So from Amgoema, we head west up the Amgoema River, maybe 100 kilometers until we find them.
Да, окей, да, все правильно.
Yeah, you're right.
Okay, fantastic.
I sense I'm gonna have to cut down on handshaking. I'm too fond of my fingers. They look so pleased to see us. Or maybe it's just curiosity. I can't imagine they get many visitors. Uh-oh. I can feel another frozen handshake coming on. Time to show off a bit of my high school Russian.
Меня зовут Spencer. Victor.
They spend their lives in temperatures that are now paralyzing me. Looking around here, I'm struggling to comprehend it all. We may be brothers under the skin, but they're obviously different. Somehow, they're better able to cope with the cold. And Nina Jablonski knows why.
The Chukchis are a classic example of what has been referred to in human biology as Bergmann's and Allen's rules. That is, in a very cold climate, the surface area of the body will be reduced and the length of the appendages will be reduced. So the people tend to have shorter arms and legs, shorter fingers, and a shorter and rounder trunk to reduce the surface area through which heat can be lost. In that way, they're wonderful furnaces, as it were, for preserving their own body heat.
And to maintain this body heat, the Chukchi have to stay physically active. For Victor, this means hard work, all day, every day. He looks after his herd of over 1,000 reindeer. I soon learned that the Chukchi are utterly dependent on them. Their ancestors hunted them, but found that life would be easier if they tamed them. Now reindeer are the Chukchi life support system. But how do these high-energy and all-providing creatures manage to survive in this frozen desert? No vegetables, no greens of any kind. The answer lies beneath the snow, in the most precious resource in the tundra, lichen. The reindeer dig down to find it. This tiny plant fueled the greatest journey ever, from Central Asia to the New World.
We're 200 kilometers inside the Arctic Circle. Eastern Siberia, mid-November, little after 3 o'clock in the afternoon. The sun has already gone down. Temperature is about minus 40 Celsius, and it's dropping at a rate of about a degree every 10 minutes, so it's going to get very, very cold tonight. One of the things you don't really think about when you imagine cold on this scale is that all of the moisture, all of the liquid is tied up in this, snow and ice. It's as though liquid water did not exist, almost like a parallel universe. And that's what life was like about 40,000 years ago as we were going into the depths of the last ice age.
And by 20,000 years ago, the world had hit rock bottom, as cold as it could get. Yet the Chukchi's ancestors survived.
Ah, this is a Yaranga.
An important lesson in Chukchi survival: eat and drink all the time. I'm starving. So, what's on the menu?
This is reindeer. Excellent.
Do you want?
I would love some, yeah.
The Chukchi diet is almost entirely based on reindeer. They use every part of the animal for sustenance. At these temperatures, nothing gets wasted. I've never eaten reindeer meat. It tastes really good, a bit like beef, but richer and higher in protein.
Yeah, don't eat from knife because it's cold and your tongue can...
Stick to the knife. Okay, so you eat with your fingers. Important to learn these things.
After supper, I'm off to bed.
We're inside the local Chukchi dwelling, known as a Yaranga, made out of reindeer skin and wooden poles. It's freezing in here. Ice covering the inside. It's about minus 30 Celsius outside. Can't be that much warmer in here. And this is where I'm sleeping for the night, inside one of these, which is sort of a tent within a tent, again made out of reindeer skin and wooden poles.
I can see that Elvis's decorator has been here.
Fantastic. It's like a reindeer in here. They've told me you just sleep in here, no sleeping bag, no blankets, just the candles and body heat to keep you warm. So, time for bed.
Believe it or not, as temperatures plummeted to 60 below outside, the Yaranga's inner sanctum kept me warm as toast.
It's so cold out here. No gloves.
Despite thousands of years of adaptation, the climate is so harsh that few Chukchi stay here to endure it.
How many people live in your group?
В нашем стойбище сейчас зимой 9 человек.
9 people in the... So the size of the group is quite small.
Во всем предприятии в оленевских бригадах у нас 6 бригад всего. И в бригадах вот такие вот по столько человек.
So in Amguya Tundra, there are only 6 brigades like here.
And is that because life is so difficult here?
Да.
Yes, you're right.
Now why are you repairing this now? It's like a sled of some sort. You're moving. How often do you have to move?
Они всегда двигаются.
Always. And it's always dictated by what the reindeer need.
Да.
Yes, you're right.
The Chukchi's ancestors had followed the reindeer eastwards. After thousands of years, they ended up here, at the eastern tip of Russia. But they couldn't go any further and were forced to make this inhospitable corner of the world their home.
The ebb and flow of Chukchi life is determined entirely by the reindeer that they herd. The things they eat, the clothes they wear, even the dwellings they live in, they all come from the reindeer. And this time of year, life is getting pretty difficult, so the herd needs to move on so that it can scrape subsistence out of the snow-covered ground here. What we're seeing right now is the village packing up to move on after the herd. Herding the reindeer together and pulling a few of them off so that they can drag the sledges with the tents.
Victor and his family are moving off, following their reindeer to new pastures, living proof that humans can adapt and survive in these extremes, and a lesson in just how little we really need to get by. But there's more. My genetic trail tells me that around 15,000 years ago, a tiny group of these Chukchi's ancestors survived to make an impossible leap into the New World. A journey which began with Niazov's family in Central Asia, then moved east along the length of Russia, left the ancestors of these incredibly tough Chukchi poised to conquer a new continent. But there was a seemingly impassable barrier to their route. The frozen reaches of the Bering Sea separate Russia from the Americas.
We're here at the Bering Strait, and it is unbelievably cold here. Clogged with ice for about 6 months of the year. Not even an icebreaker can get through. And yet we know that the ancestors of the Native Americans made it through here about 15,000 years ago at the height of the last ice age. How could they have made a trip like that?
I followed the trail of the first humans from Africa to the eastern tip of Russia. I've met their descendants, the Chukchi. But blocked from reaching America by the Bering Sea, I can go no further. Yet I know the blood of these Arctic herdsmen connects them to Native Americans. How did they get there? In an ironic twist, the ice age that drove us out of Africa now provided the Chukchi's ancestors with an escape route. As temperatures fell and sea levels dropped, a new landmass called Beringia was exposed from beneath the Bering Sea. This new land connected the Russian Far East to Alaska. The reindeer headed for new pastures. The few survivors followed them, taking mankind into uncharted territory, into the New World.
The sea level was very much lower. About, you could build a 40-story building, to tell you how much the sea level had changed. But they couldn't go very far. They were sort of stuck in northern Alaska because of all the ice.
And behind them, things weren't much better. As the Ice Age came to an end, sea levels rose again, marooning the first Americans on a tiny pocket of land. Yet they survived. An escape route appeared.
The first Americans arrived here only about 13,000 years ago. And they probably walked from Alaska down a corridor that existed certainly about 11,000 years ago along the eastern side of the Rocky Mountains. There may have still been ice to the east and the west, but there was an ice-free corridor that they could have walked down, and they arrived in North America. It was essentially an empty environment from their perspective with lots of rich resources.
A journey that had begun in Africa, divided in Central Asia, had now reached the last continent. For thousands of years, they had endured the most extreme conditions on Earth, and now this branch of mankind had found a new home.
Our ancestors were pretty tough people. They'd survived drought, famine, and an ice age in order to get this far. Yet our genetic results tell us that the first group to make it through to the Americas had been whittled down to as few as 10 or 20 individuals. Today, their descendants are carrying, written in their DNA, evidence of those hardships thousands of years ago. But when they did get through, what was their reward? A land of plenty. They'd never had it so good.
After 10,000 years of struggling through the tundra, these Arctic hunters hit the jackpot. As the ice gave way to the rolling prairies, they found a new land in which to live and prosper. Their numbers swelled, and in only 800 years they had peopled both North and South America.
I'm off to meet an ancient tribe who traced their family line back to Siberia, to the ancestors of the Chukchi who made that first migration into the Americas. They're the Navajo, and they live here in Canyon de Chelly, Arizona.
The Navajo Indians have been living in North America ever since their Chukchi ancestors first arrived. Canyon de Chelly is one of their most sacred sites. I wanted to tell them about the genetic trail that had led me to them. But I soon learned they had migration stories of their own.
Thanks a lot for inviting me up here to your place.
You're welcome. Enjoy having you.
It's gorgeous here.
We're glad to share the information about our place here.
Can you tell me a little bit about the place, how long you've lived here?
This is the junction of Canyon de Chelly. We got this piece of land from my great-grandfather.
This is our hogan.
We have a story of where we came from, and our story, our origin is a very sacred stories, and it's passed on through generations, and that's your life and your way of where you came from. And I'm sure that these two has some other information too.
Phil Bluehouse explained.
Well, adding to what Letty has to say, there is a creation and journey narrative that we go back to, and this narrative is quite sacred. It talks about the event of creation. We call that a Hajine in Navajo, or at the time of beginning.
Do you have any stories about where the ancestors, the ancestors of everyone may have come from?
It depends on how you, there are discussions about migrations. I mean, when we migrate from our mother onto the Earth's surface, that is a migration narrative. I mean, we come from one being to another. That's a migration. If we believe that we were created here in the Four Sacred Mountain area, this is where we came up from the ground. In other words, we were birthed into this place, just like we are all birthed by our mother.
I also have my own sense of what that story might be using science. I'm a geneticist. And everybody around the world is very closely related to each other. We're all part of one big family. In fact, we're all related to people who lived in Africa as recently as 50,000 years ago. That's only about 2,000 generations. So you have distant relatives living all over the world who are essentially African. And you yourselves are essentially African. So am I. Can I show you some pictures of some of the people we've met?
Yep.
These are people known as the San Bushmen who live in southern Africa. And they are some of the oldest people on the planet.
Are these the people that have that clicking sound?
Exactly.
Yeah.
Okay, exactly. Fascinating people. Now, the evidence is that the first people who left Africa followed a coastal migration route along the south coast of Asia, and they ended up in Australia. The Australian Aborigines. We visited them.
So you're basing this on the genetic trail?
Exactly.
Now, these people who were in Australia, they mainly were more together as a group, you know, like
more cohesive.
More cohesive, and
there are lots of different populations in Australia, speaking very different languages. They have different cultures, different myths.
Why do you call something that a people will tell you a myth, as opposed to an experience that they had and they relive it over and over, rather than calling it a myth? Would be able to call it something else, because I have a real strong feeling about that. That, you know, if we call something a myth, it's a substandard event that does not have any relevance, because they are real as we understand them. They're not myths. And
absolutely, that's a very good point. And my bias as a scientist is that I like to see evidence for things.
Yeah. Okay.
So that was the first migration out of Africa, according to the genetic results that we got. Now the next one followed a slightly different route, one that went inland.
I'm getting pretty good at this. Of course, it helps that I brought the family album along.
And this man is a direct descendant of a person who lived in Central Asia about 35 to 40,000 years ago.
Wow.
And his ancestor is also the ancestor of most Europeans and Native Americans.
Wow.
He's a man called Niazov. who lives in Kazakhstan.
Are you the same person that did some research I noticed on the internet that says that the Native American people are somehow connected to
Yes.
Central Europe?
Yes, Central Asia.
Central Asia.
Yeah, that was a paper that we published last year.
Okay. That's good to know.
What do you think of that?
You know, and I was looking at a book from people from Central Asia, and I saw my cousin Emmett and Abraham, Auntie Grandma Buggy, and I said, my God, I got family over there in Central Asia. These were the Mongolian people.
Yeah.
Central Asians.
Yep.
Oh, yeah.
That's it right there. In the eye, he looks like Oriental, and then he's got Negro features to some extent, and also Caucasian, kind of all mixed together. So that's interesting, very interesting.
These are the Chukchi people, and they're your
They're still
distant
in
cousins.
Siberia.
They're still living in northeastern Siberia. I visited them recently.
Oh, they're the ones that have
With the
this
reindeer.
With the reindeer.
Reindeer. I've seen them on TV.
Their home is...
They're
Yeah, the home looks like a teepee. And the results show that they are your ancestors. They ultimately made that trip across the Bering Strait into the Americas.
Wow. About how tall were these guys here?
About 5'8", 5'6", 5'8". Yeah,
About
not too
tallest?
tall. Yeah. And by looking at the genetic data, we can estimate that as few as 10 or possibly 20 people were in that first group, the first wave of migration into the Americas. Yeah.
My story about the journey of man came as no surprise to these Navajo. The idea of migration had been central to their own creation story since the beginning of time.
The point is that somehow we're finally acknowledging one another from the scientific realm and from the traditional realm, saying that, yeah, the puzzle is starting to fit together.
And we complement each other.
And we're all complementing each other.
Our research tells me that the last stage in the greatest journey ever made could have been completed by only 2 or 3 men and a group of as few as 10 people. Just 10 extraordinary people.
Once they got down there, they discovered that there were a lot of big grazing animals all over the place there too. American buffalo, mammoths, all sorts of things. And they kept spreading south, and in about 800 years, they actually got all the way down through South America.
It took our ancestors, those first humans, around 35,000 years to make the perilous journey from Africa to the New World. Today, nearly 500 generations later, their descendants can make the trip in less than a day, from anywhere in the world. And every year, for about 5 days, nearly 1 million people do precisely that. They come here to Rio de Janeiro for one of the most exuberant celebrations of life anywhere in the globe. That's why I've chosen to end my journey here. Years ago, this story would have been impossible to tell. The scientific technology simply didn't exist. But in this era of globalization, isolated populations are being absorbed at an ever-increasing rate. It's possible that by the end of the century, the genetic signposts of our journey will have been dispersed around the globe. When this happens, the story will once again become hidden. My colleagues and I have been very lucky to be able to tell this story, to decipher the genetic clues during this brief window in history.
My journey around the world has only been possible because of some unusual people. The Navajo Indians from Canyon de Chelly, the Chukchi reindeer herders from the Russian Far East, the people at the crossroads in Central Asia, and the Australian Aborigines. Yet we can all trace our ancestry back to those few people who left Africa 50,000 years ago.
Heads up, girls and boys. 1, 2, 3.
I'm from Liberia. I'm African and Native American.
I'm from New Zealand. My father is Welsh and my mother is Greek-English.
I'm from Denmark. My father's Danish and my mum is Thai.
I'm from the Caribbean. My father's African and Spanish. My mother's Irish-German.
I'm Slovakian. That's it.
Ignore whatever I say. That's lovely. Don't do it. It will be the one they choose.
So, I've reached the end of my journey. And what have I learned? Well, a lot. I've been humbled by the courage and resilience shown by our ancestors. And I've witnessed firsthand the powerful combination of intelligence and the human spirit. And reassuringly, I've proven to myself that all those years in the lab weren't wasted. The story carried in our blood really is true. But there's one lesson that stands out from all the others. It's a lesson about relationships. You and I, in fact everyone all over the world, we're all literally African under the skin. Brothers and sisters separated by a mere 2,000 generations. Old-fashioned concepts of race are not only socially divisive, but scientifically wrong. It's only when we've fully taken this on board that we can say with any conviction that the journey our ancestors launched all those years ago is complete.